Here we go with our first hypothesis test. This is from the on-the-board exercises in your workbook. Maybe we should call them on the desktop or something like that, because I'm doing them on the desktop rather than on the board. But let's go ahead and read this question. This question says, does smoking stunt women's growth? A team of researchers wanted to know if smoking during teenage years was associated with smaller stature for women. They randomly select 64 women who smoked for at least 5 years during their adolescence and found that they had a mean height of 62.4 inches. According to the National Center for Health Statistics, the mean height of women in the U.S. is 63.85 inches, and the standard deviation is 3.82 inches. Is there any evidence that women who have smoked are shorter than average? This is ripe for a hypothesis test, and I'll teach you guys how to do that through example, essentially. I'll show you how we do a hypothesis test using the 6 steps through there. But to start with, remember the population mean we have designated here, 63.8. And just as a point of fact, if we took a sample of women, of 64 women, we wouldn't expect that their height to be exactly 63.85. We might expect that we get a little sample variability. It might be 62 sometimes, it might be 64 other times, it might be 65, it might be 63. The question is 62.4 so out of the ordinary in expectation as to be truly different from this distribution or from the distribution that gives us that mean? That's the nature of a hypothesis test. So first I'm going to start by just enumerating or listing the 6 steps of hypothesis testing. The first one being state and check assumptions. And we'll talk through exactly what that means in a minute. I'm just going to list down the 6 steps to get us started. The second is that we're going to generate a null and alternative hypothesis. I'm abbreviating it here as HO is the null hypothesis. The alternative is HA. Step 3 is we're going to choose a sampling distribution to work with. Step 4 is we're going to set a significance level. Step 5 is we'll compute our test statistic. And 6 is we will draw a conclusion. Okay, and draw a conclusion. What am I talking about? A conclusion, whatever. Okay, so let's start with the top, okay? As I noted in the lecture, there are 3 parts or 3 things that we need to check our assumptions about. The first is about the population. So I'm just going to write population here. And the first thing that we ask is the population normally distributed? And frankly, I don't know. I don't know if the distribution of women's heights is normal. It may be, it might likely be, it probably is if I thought about it, but I don't really know that. But is N sufficiently large enough so that the central limit theorem takes over? And the answer to that is yes. The last thing I need to know is do I know anything about population variance? And yes, that's given as 3.82. The second questions that I have, the second series of questions I have to ask are about the data. And specifically what I'm asking about is level of measurement. And in this case, we have interval or ratio level data. The data are women's heights. So a height, a length, a time, those are interval level measurements. The last assumption I have to check is about the sample. And the question that we ask is the sample random? And it has to be in order for this to work, or I certainly hope so. All right, I hope so. So that's our stating and checking assumptions. We have a large enough n so that the central limit theorem will come into play if we don't have a normal distribution. We know population variance. We have an interval ratio level of measurement, and we hope we have a random random sample, and that's what they told us that they randomly sampled these. Okay, our null and alternative hypothesis. I'm just going to state them like this. I'm going to put HO colon, HA colon. Property of the HO is that it's very specific. It's about a population parameter. It's no change, no difference, no effect. Okay, so the first thing is it's about a population parameter. It's about the mean. In most cases, we're going to be interested in where the scores tend to be. So what we're saying is the mean of women's heights who smoke is not different. It doesn't change. There's no effect of smoking. If that's in fact the case, then the mean height of women will equal, who smoke, will be 63.85. Now, if smoking does stunt growth, then the mean will be less than 63.85. That is our alternative hypothesis. The alternative hypothesis is about the same population parameter, but it's a much more general. There's a lot of values that are less than 63.85. There's only one value that is exactly 63.85, and that is 63.85. Okay, so now we go to step 3. Because we're interested in one mean, because we know the population standard deviation, we are allowed to do what we call a z-test for one mean. Okay, those are the requirements in order to do this test. We need be testing one mean. We need to know sigma, and we're going to use a z statistic in order to test that. Setting our significance level, what we're doing is we're setting alpha. What that means is that's going to be sort of like our confidence level. How confident do we want in our ability to make the right decision, so to speak? This is much more complicated than that, but let's just say that we're good psychologists and that we set our significance level at 0.05. What that means is that something akin to we have a 95% chance of making the right decision under certain conditions. I should add that this is also when we call set our decision rule. And our decision rule is very easily stated. If P is less than alpha, we reject the null hypothesis and accept the alternative hypothesis. If P is greater than alpha, we fail to reject and fail to accept. That's and to accept. You're writing right there, buddy. There we go. Okay, and this should be and. We'll write that and. Okay, so that's it. Now we compute the test statistic. And the test statistic is fairly easily computed. Let's write down first what we know. Okay, so for step 5 of our hypothesis test, right? For step 5, now we're going to do some quick computations. This is going to vary in difficulty depending on the situation on the test. What we know from the question is that we have an n of 64, that sample mean, the mean of that sample was 62.40 inches. We know that the population mean is equal to 63.85, and we know that the population standard deviation is 3.82. Okay. Our z statistic takes on the form z is equal to m minus the mu of m divided by sigma sub m. And we all know mu of m is the mean, population mean of the sampling distribution of sample means. And this is the standard error of the mean, or the standard deviation of the sampling distribution of the sample mean. We know from the 3 amazing facts that mu sub m is equal to mu. And the second amazing fact is that sigma sub m is equal to sigma divided by the square root of n. So in this case, mu sub m is equal to 63.85. Sigma sub m is equal to 3.82 divided by the square root of 64, or that is equal to, if we do a little math, 4.775. We know that our mean is equal to 62.40. So we have all that we need to do this computation. So z is equal to 62.40 minus 63.85 divided by 0.4775. And if we do the math, we get negative 3.03. What does that mean? What that means is we know that under the condition of selecting 64 observations with a mean of 63.85 and a standard deviation of 3.82, that means will be normally distributed around 0 if we do a z transformation. Minus 1, plus 1, this is a normal distribution, plus 2, minus 3, plus 3. This is a normal distribution, and our mean, the mean of our sample, came in way out here. Okay? These, of course, are the conditions of the null hypothesis. If the null hypothesis, the probability, or if our null hypothesis is true, our mean has a z-score of minus 3.03. That particular probability is less than 0.01. This area over here is less than 0.01. In other words, if the null were true, then the probability of our results, given the null is true, is less than 0.01. This is our p-value. Okay? All right, so if we get back to our hypothesis test, what we find is we calculate a statistic z is equal to negative 3.03. P is less than 0.01. If we made it 0.01, that's fine, and that's fine. Now, drawing our conclusion, all we do now is apply the p to this decision rule right here that we made earlier. Okay? Is p less than alpha? Our p-value is much lower than 0.01. Is this lower than 0.05? Yes. Our p is less than alpha. Therefore, we reject the null hypothesis and accept the alternative hypothesis. Okay? Now, the null hypothesis says that the mean height of women smokers, or women who have smoked in their adolescence, is 63.85. We've rejected that and accepted the fact, we've accepted the statement, the mean of women who smoked in adolescence is less than 63.85. So it appears to us that women who smoked during adolescence are smaller in stature. And that is our conclusion.